Hello everyone. So in today's session we will be seeing big theta in detail. So in the previous videos we have seen already big O notation and big omega notation, where big O was acting as a upper bound for a time function and big theta was big omega was acting as a lower bound for a time function. In the case of big theta, it actually gives a range. Okay, it says that the function f of n will be in a particular range, or you can say it will point to a particular class in the time function. So suppose if you say f of n is equal to n square plus 5, it will point to a particular class big theta of n square. It cannot be big theta of n cube and it cannot be big theta of n log n. We will see how it works. And first we will see the graph for that. Suppose if we are having a function f of n, and if we have to say f of n is theta of g of n, then it should satisfy this given condition. C1 into g of n should be always less than or equal to f of n, which is less than or equal to C2 into g of n, which means you are having a function g of n, and for two different positive constants C1 and C2, C1 into g of n should be acting as a lower bound for f of n, and C2 into g of n should be acting as an upper bound for f of n. If this condition satisfies, then I can say f of n is big theta of g of n. Okay, we will see the formal definition as well. A function f of n is said to be theta of g of n if and only if there exists three positive constants c1, c2 and n0, such that c1 into g of n is less than or equal to fn is less than or equal to c2 into g of n for all the values of n greater than or equal to n0. So from a particular point onwards, if you check, c1 into g of n will be always less than f of n, and c2 into g of n will be always acting as an upper bound of f of n. We will see it with an example. So consider a function f of n is equal to 2n plus 5. We are going to find a big theta for this function. Okay. So what I am assuming is that I am taking g of n as n, I am taking c1 as 1 and c2 as 7. c1 as 1 and c2 as 7. We will try to draw the chart. So for different values of n, the value of f of n will be 5, 7, 9, 11, 13 and 15. Here f of n is 2n plus 5. And for c1 into g of n, I am taking c1 value as 1. So it will be same as n. 0, 1, 2, 3, 4, 5. Here you can see for all the values of n which is greater than or equal to 0, you can see that c1 into g of n is having a lesser value than f of n, which means c1 into g of n is acting as a lower bound. And what about c2 into g of n? You can see from n value greater than or equal to 1 onwards, you can see that c2 into g of n is greater than or equal to f of n, which means from this point onwards, or from 1 onwards, c2 into g of n is having a value which is greater than f of n, which is acting as an upper bound. Okay, so I can say that for a value n greater than or equal to 1 onwards, you can say that c1 into g of n is less than or equal to f of n, and f of n is less than or equal to c2 into g of n. So I can take an n0 value as 1. I can take 2 also. Suppose if I take n0 value as 2, here also you can see that c1, so n0 value as 2, c1 into g of n is 2, which is having a value less than 9, and c2 into g of n is having a value 14, which is greater than 9. Similarly, even if I take n0 value as 3, then also the condition is true. So n0 value can be anything from 1 onwards. What if suppose I take n0 value as 0? Can I satisfy this condition? It is not possible, because for a value n0 0, c1 into g of n is acting as a lower bound, but c2 into g of n is not acting as a upper bound. So n0 cannot be 0, it can be any value from 1 onwards in this particular case. Okay, I hope it is clear for you. Now another question is that, can I take function g of n as, say, n square? Suppose if I can satisfy this condition with g of n as n square, then I can say this function f of n is big theta of n square. But if you try to prove it, you can see that it is not possible to do so, because for any positive constant value c1, at some point of time the function g of n, c1 into g of n, will become greater than f of n, which means it will become a upper bound. So this cannot be satisfied. So to generalize the asymptotic notations, suppose if I say a function f of n is big O of n square, the meaning is that it takes a maximum of n square time. Suppose if we are having a function f of n, or if we are having an algorithm which take a time complexity f of n, the run time or the execution time will not exceed order of n square time. So anything from n square onwards is big O, big O of g of n. This means g of n can take value n square, n cube, 2 power n, or up to n power n. Could take any values. Okay. And if I say f of n is, say, big omega of n square, the meaning is that it will take, or it is acting as a lower bound. Minimum it require order of n square time. To complete that function, it requires a minimum of n square time. It can be greater. Okay. So from n square onwards, anything to the left of this ordering, this increasing order of triangular complexity, will be, you can say, as big omega. So this can be, if you write big O of n, this will also be true. And if you write big O of log n, that also will be true. Which means it will take at least log n of time, or anything above that. Okay. Similarly, here you can say order of n cube. Anything to the right is true for that. And suppose if you say f of n is theta of n square, the meaning is that it belongs to that class. It cannot be theta of n cube, it cannot be theta of n log n. It should be in the class n square. So actually theta function will be giving a precise information on the time complexity. But it is not possible to give a class function to all kind of programs. So mostly we will be using a upper bound, which is big O. We will be using a bigger notation. Thank you.